All right, welcome to whoever's watching this. Today I'm going to be talking about phytic acid and the biochemistry of seeds. So sit back, relax, grab a snack, grab a drink, and let's just get straight into this. So, a fair warning, this presentation might disagree with what you previously know about nutrition. Most modern nutrition advice is actually based on outdated data from the 1960s, and we actually don't even teach that much nutrition anyways. And some of this outdated data includes the food pyramid, which is probably one of the worst decisions ever publicized by the US government, the US subsidization of grains, and modern inflation, which allows the average person to get less access to nutrient-dense foods. So take what I say today with a grain of salt, because modern science actually really changes a lot. So what I say in 50 years from now, it might still be true, or it might also not be true. So that being said, take it with a grain of salt. All right, so let's get into some background. So there's a sort of language around bioavailability. And if you don't know what bioavailability is, it's the fraction of an ingested nutrient that becomes available for use by the body. And this is based on absorption in the gut and in the entire digestive process. And if you don't know what a nutrient is, there's macronutrients like carbohydrates, proteins, fats, but there's also micronutrients, which are also not really talked about enough. And this includes molecules like vitamin A, vitamin K, vitamin B, different metals that we know from the periodic table, salts, electrolytes, and these are all used again by the body for different functions in the brain, in our muscles, everywhere really. If you don't really have a concrete understanding of bioavailability, I'm going to give you an example right now. I'm pretty sure 300 micrograms of vitamin A is the daily value set by the US government. So really you could be eating 300 micrograms of vitamin A, but that doesn't mean you're actually using or absorbing 300 micrograms of vitamin A. You could only be using or absorbing half of that, like 140, 150 micrograms. And really that's the nature of bioavailability. And it really depends on foods you eat. And also depends for metals on the isotope. Your gut is actually really picky about what it decides to absorb and what it decides not to absorb. Same with the bacteria found in your gut. And it also depends on the charge, because then again, if you really think about our body, it's a ton of chemical processes. And we know that charge really has an effect on different reactions. So bioavailability, keep that in mind. I'm going to say it a lot. One more piece of background is the goal of a seed. Let's think evolutionarily about a goal of a seed, which is really to spread a plant, spread the parent plant. Animals will eat a seed, they'll walk around, and then basically they'll poo out a bunch of seeds. Some of them will be digested, some of them will not be digested, and then some of those seeds will sprout into a new plant. And there's a battle between the digestive system and a seed. The digestive system wants to eat the seed doesn't want to be digested. So what the seed has done is actually grown enzymes and compounds in their seed coats that prevent it from being digested. So let's look at this through the lens of a common misconception. Which do you think is healthier, brown rice or white rice? Brown rice is the whole grain version of rice that contains the whole of the grain, while white rice does not contain the whole. Surely it's whole grain brown rice, right? Long story short, it's actually not. In fact, ancient cultures have even preferred white rice for millennia. But why would they go through all this effort, this extra effort of removing the whole of rice? So even modern science actually even says that the whole contains extra nutrients, brown rice is better, and it also has a slower effect on blood sugar, which technically is true. But that approach ignores really two important issues. There's anti-nutrients, so much more anti-nutrients in brown rice. And the minerals that are actually available inside the brown rice, they're not that bioavailable. We can't actually absorb them that well. And let's see why this is. So seeds are evolutionarily not meant to be consumed. Stomach acid contains salts, but mostly hydrochloric acid, and contains a pH of 1 to 3. And this high acidity environment is actually what allows us to digest all these complex proteins, fats, and carbs. So really, how do seeds survive in this environment? So they've evolved to have oils, and waxes that are hydrophobic, but this difference in polarity actually protects them from the hydrochloric acid. They're non-soluble in it, and it sort of forms a protective layer around the seed. Keep in mind, though, that this only really works if the seed is not damaged in a previous step of digestion. So there's also biopolymers inside the seed, and there's acid hydrolysis, which is really a complex organic chemistry reaction. But I'll talk about the general premise of hydrolysis, which is really just having a large molecule, you react it with water, and it breaks down into two smaller molecules. And if you think about the digestive system as a whole, this really makes sense because we're trying to break down complex structures and use them for their energy. So there's complex biopolymers, there's oils, but there's also anti-nutrients like phytic acid, which bind to minerals inside of our gut and are helped to use that are used in the germination later. They also help the fertilizer, if you could say that, for the seed later on. So phytic acid is known as an anti-nutrient. It inhibits the bioavailability of zinc, iron, calcium, phosphorus, chromium, and manganese. But this really extends to really many other metals as well. It's found in many seeds, legumes, and grains in high amounts, but it's found in the whole and bran of grains. So if we think back to our brown rice, white rice example, this is probably why ancient cultures have been removing the whole, because they've seen negative health effects that are associated with it. So it's really helpful for the plant because it gets all of these extra minerals, but it's not really helpful for the host. So let's see how phytic acid works. So there's two diagrams of phytic acid on the right. Phytic acid binds to nutrients and it chemically alters them to form a salt, which is phytates, which are called phytates. Phytates are phytic acid in their salts. They bind near the hydroxides around the edges, and really they effectively steal minerals from inside the gut. And that leads to mineral deficiencies because phytates are insoluble, and mineral deficiencies are really bad. I think we all know that. So this is a visual diagram of how phytic acid forms these phytates. You can see sodium phytate, zinc phytate, calcium phytate. Really, again, as I said before, the list can go on and on and on. Okay, so there are some ways that we've been able to reduce phytic acid. Herbivores have actually evolved to have a way to reduce phytic acid. They have multiple stomachs, which helps them on average digest a seed more often, but they also have phytase that's produced inside their stomach, which is an enzyme. And we can see down below another reaction where phytates are actually broken down into smaller components. And this is also put in modern animal feed because we're feeding them a lot more seeds than they're used to. But yeah, we're omnivores. Unfortunately, we don't have phytase and we only have one stomach too. So we're really evolutionarily evolved to eat animal products, fruits, vegetables, and not really seeds. That being said, we still have developed some ways to reduce phytic acid through sprouting, cooking, soaking, fermentation. Sprouting really helps get rid of those phytates and the phytic acid. Soaking, phytic acid is actually water soluble, so that you can actually soak out the phytic acid. And there's also intense processing that is done. So some of these intense processings involve intense heating that break down the seed coats that we talked about earlier, or there's synthetic solvents that are used, especially for seed oils, which again are totally terrible for you. They stay in your cell membranes for up to 7 years, and they're really associated in multiple studies with high levels of cancer. They're also ground and bleached into flours. Wheat flour, for instance, you process the crap out of it. Basically, it makes it more digestible. And this process does not work 100%. It really leaves anti-nutrients like phytic acid inside the flour, and this is really why we want to have a new way to get rid of phytic acid. So my solution is to use something called a supercritical fluid. A supercritical fluid is both liquid and gas at the same time. We can see on the diagram at the right that at high temperatures and high pressures, a substance becomes a supercritical fluid, and it retains important properties of both. liquid and gases. It can effuse through solids like a gas, but interesting enough, it can actually dissolve materials like a liquid. And the most famous example of this being used is for decaffeination for coffee beans. You can actually take supercritical carbon dioxide, put it in a tight container with these coffee beans, and after some time, the caffeine will be gone. It will be dissolved inside the supercritical carbon dioxide, but you remain the bean itself remains intact, and it has all the flavors still there. So again, decaffeination used supercritical CO2, but if we think about what I mentioned earlier, phytic acid is actually water soluble, and we can actually use supercritical water probably to dissolve this phytic acid in an industrial process, and we can do that to all beans, grains, and seeds. And this will greatly increase the bioavailability of these nutrients inside the seeds themselves, and it will not rob us of minerals inside of our gut anymore. And to my knowledge, this has not been done yet, but it'd be a very easy process because we already have the infrastructure in place for decaffeination. So some takeaways from this presentation is that we really should be removing phytic acid from all seeds, all grains, all beans through supercritical water desolvation. But until this becomes an industrial process, I would stick to what we are evolved to eat. So that'd be getting rid of seeds, especially seeds that are whole grains. So I'd remove the following from your diet: whole wheat, any sort of seed, pumpkin seeds, sunflower seeds. You can actually see when you eat pumpkin and sunflower seeds, they're not actually digested. I'd take away brown rice, beans, corn, and soy. Obviously, it's really hard to remove entire things from your diet. So I'd opt for actually more healthy, nutrient-dense, nutrient-intact replacements like sprouted wheat instead. Get sprouted wheat flour, or I'd eat highly fermented breads like sourdough. And I'd replace brown rice with white rice, although I would be careful with that because it does spike your blood sugar. I would soak your beans, maybe even sprout your beans before you eat them. And I'd just take corn out of your diet completely. We really shouldn't be eating corn. That's, again, another topic. But for soy, I would eat fermented versions like natto and miso. Really, the main takeaway here, and what we've learned from the 1960s, is that we really should be evolving. We've evolved in a certain way, and we should be eating in a way that we have evolved to digest foods like. So we're not herbivores. Don't eat like an herbivore. We're omnivores. We got to eat meat. We got to eat plants. We got to eat fruits, not seeds. So really, I would replace or eat more meat and organs. Organs are the most bioavailable source of nutrients on the planet. We've been eating them for millions of years, and you can actually see animals, they go straight for the organs right away. They don't go for the meat, they go straight for the organs. They know how nutrient dense these organs are and how good it is for their health. So yeah, I would eat more meat, more animal products, more organs, more eggs, very nutrient dense, although I would not overcook the yolk because that leads to higher levels of cholesterol in the bloodstream. I would eat fruits. Again, we are omnivores, so we do have to eat fruits and plants, although some vegetables contain high levels of phytic acid too. So I'd keep in mind that. So really, I hope today you enjoyed it. I hope you learned something new. Here are some of my sources. Again, I could source many articles that I read, but these are the most helpful ones. And if you found this at all interesting, I'd check out Mark Sisson's blog, The Primal Blueprint, or this book, The Perfect Health Diet by Dr. Paul Jaminet and Shoching Jaminet. They had a bunch of sick. They were very sick for a while, and then they switched to an evolutionarily appropriate diet, and all their illness went away. Really interesting story. But then again, I hope you learned something new because we really don't teach nutrition enough. All right.